Hello everyone. In this video, we will learn all about rational exponents. To begin with, let's review this one. Given the exponential form 2 to the power of 4, 2 here is considered as the base, 4 is considered as the exponent. It could be power or index. Now, expanding this, we will get 2 times 2 times 2 times 2, or this is 16. 2 to the power of 4 is considered as the exponential form. This is the expanded form, and 16 is the numerical value, or basically it's the standard form. So take note, when you say exponent, it will save us from writing multiple numbers. Okay, now write the following in exponential form. 16 could be written as 4 squared, or it could be 2 to the power of 4. 49 is 7 squared. 27 is 3 cubed. 64 could be written as 8 squared, 4 cubed, or it could be 2 to the power of 6. Negative 32 is negative 2 to the power of 5. 81 could be written as 9 squared, or it could be 3 to the power of 4. 125 is 5 cubed. 0.25 is 0.5 squared. And 0.0016 could be written as 0.04 squared, while 4 over 9 could be written as 2 over 3 to the power of 2. Now, in simplifying rational exponents, it's very important that we are going to review about the laws of exponents. So let's start with the product rule, in which if you multiply exponential terms of the same base, copy the base and add the exponents. So just like x4 times x5, it's the same as x to the power of 9. Copy x, and 4 plus 5 is 9. Another is the power rule. If you have an exponential term raised to an exponent, simply multiply the exponents. So just like this one, 4 times 2 it's 8, and 3 times 2 it is 6. Another, it's the power of product rule. So if you're given xy to the power of 4, you can distribute the exponent to the terms inside. Another, quotient rule. When you divide exponential terms of the same base, copy the base and subtract the exponent. So just like this, 10 divided by 5 is 2, 5 minus 4 you'll get 1, and 7 minus 3 will get 4. Another, power of quotient rule. So if you're given x over y to the power of 2, still you can distribute the exponent to the terms inside. So it's the same as x squared over y squared. Another, we have the law of fractional exponents, in which a to the power of m over n, it's the same as the nth root of a to the power of m, or that is nth root of a to the power of m. So just like this, x to the power of 2/3, that's cube root of x squared, or that's cube root of x to the power of 2. Okay, now take note, these are basically the laws of exponents with their corresponding examples. Now, another important thing that we need to consider is the exponents of exponents. So 4 cubed to the power of 2, this is different from the power rule. So this is an exponent of exponents. So how to do this one? So given with 4 cubed squared, so take note, 3 to the power of 2, that is 9. So it will become 4 to the power of 9. And simplifying this, we will get 262,144. Again, take note, exponents of exponents is different from power rule. Okay, another, the strange case of 0. So take note, any number raised to 0 is always 1. So with this, x0 is 1. 0 to the power of x is 0. 0 to the negative x is undefined. And 0 to the power of 0 is indeterminate. Now take note of this 1. Okay. Now take note, all you need to know about exponents is the exponent says how many times to use the number in a multiplication. A negative exponent means divide because the opposite of multiplying is dividing. And last, a fractional exponent like 1 over n means to take the nth root of x to the power of 1 over n is basically nth root of x. So again, take note of this 3. If you understood this one, then you understand about exponents. Okay, let's have this one. 3m squared and 5 to the power 4. So to do this, 3 to the power 4, that's 81. 2 times 4, that's 8. And 5 times 4, it is 20. Another. 4m8 n squared times negative 2m n 4. So with this one, 4 times negative 2, that's negative 8. 8 plus 1, so we'll get 9. And 2 plus 4, we will get 6. So take note. Another. 2a squared b cubed c4 to the power of 3 multiplied by negative 3ab to the power of 2 multiplied by negative b cubed c to the power of 3. So to do this, we have to simplify each term. So let's start with the first. So take note, 2 to the power of 3, that's 8. A squared to the power of 3, that's a6. B cubed to the power of 3, that's 9. And c4 to the power of 3, it's 12. This one, negative 3 squared is positive 9. So this would become a squared and b squared. So this one, negative b cubed to the power of 3. So that would be negative b to the power of 9. And c to the power of 3, that's c cubed. So at this point, let's simplify. 8 times 9 times negative 1, that's negative 72. A6 times a squared, that would become a8. B9 times b squared times b to the power of 9, that would become 20. 9 plus 2, that's 11. Plus 9, it's 20. And c12 times c cubed, that would be c15. So take note of this. Okay, another. 24x to the power of 7, y squared divided by 4x cubed, y cubed. So at this point, let's divide. 24 divided by 4, that's 6. 7 minus 3, that's 4. And 2 minus 3, that's negative 1. So take note, this is negative. So simplify further. So 6x4 over y. Another. 2x cubed over 3y to the power of 4 raised to 2. So simplifying this, let's distribute 2 to the terms inside. So 2 to the power of 2, that's 4. Then 2 times 3, you will get 6. 3 to the power of 2, that's 9. And 4 times 2, you'll get 8. Okay, one last. Okay, 2x squared y cubed to the power of 5 divided by quantity 4x y cubed quantity squared. So the same thing, let's distribute the exponents to the terms inside. 2 to the power of 5, that's 32. 2 times 5, that's 10. 3 times 5, it's 15. 4 to the power of 2, that's 16. X squared, and 3 times 2, you'll get 6. So simplifying this one further, 32 divided by 16, that's 2. 10 minus 2, that's 8. And 15 minus 6, you'll get 9. So therefore, this is a simplified form of this one. Okay, now let's have 0 and negative exponents. Take note, any number raised to 0 is always 1. 5 to the power of 1, that's 5. 5 squared is 25, and so on. When you go down, 5 to the negative 1, it's 0.2, or that's 1 over 5. Then 5 to the negative 2, that's 1 over 5 squared, or that's 0.04. Now take note, as the exponent increases, the value of 5 also increases. But as the exponent decreases, the value of 5 also decreases. So take note of this. Okay, 0 power. So take note, any number raised to 0 is always 1. So 4 to the power of 0, this is 1. 1 over 3, 0. So this is 1 over 1, or simply it is 1. Another, 3 over 4 to the power of 0. So still this is 1. Another, 6, 0 plus 5, 0 minus 4 to the power of 0. Substitute, we'll get 1 plus 1 minus 1, or simply it is 1. Okay, another, negative power. So x to the power of negative n is the same as 1 over x to the power of n. Example, if you're given 6 to the negative 1, it is the same as 1 over 6. Another example, 2 to the power of negative 4. So make it positive. So 1 over 2 to the power of 4, which is 1 over 16. Another, 1 over 6 to the power of negative 2. So bring this up. So that would become 6 squared, or that is 36. Another, 3 over 5 to the negative 2. So since this is negative, so bring it up. So to make it positive, so 3 times 5 squared, so that is 25. So simplifying, you'll get 75. So take note, when you say negative power, make it positive by bringing it up or bringing it down. Another, power of quotient. So take note, if you're given x to the negative a over y to the negative b, so make it positive. So if this is x negative a, bring it down. So this one at the bottom, bring it up. So let's have an example. 1 over 5 to the power of negative 1. So to make this positive of positive exponents, we will simply reverse the base and make the exponent positive. So 1, 5, so make it 5 over 1, or simply it is 5. Another example, 3 over 4 to the power of negative 3. So to make the exponent positive, reverse the base and make the exponent positive. So 3 over 4, so this would become 4 over 3 and make the exponent positive. So simplifying, you will get 64, and 3 cubed is 27. Another, this one, 4 to the negative 3 divided by 5 to the negative 2. So again, when you say negative exponents, it's either you bring it up or bring it down. So this one, 4 negative 3, so make it the denominator 4 cubed. 5 negative 2, so bring it up, you'll get 5 squared. So simplifying, this is 25 over 64. So take note, when you say power of quotient, so it's either you bring it up or bring it down. If it is a fractional base, simply reverse and make the exponent positive. Another important thing to consider in solving rational exponents is about equal powers. Equal power states that x to the power of a is equal to y to the power of b if and only if x is equal to y and a is equal to b. Or if simply means if the bases are equal, you can equate the exponents. Let's have an example. Given 3 to the power of x minus 2 is equal to 81, solve for x. So at this point, the base is 3. So with this, we need to rewrite 81 to the base of 3, in which if we simplify, 81 to the base of 3 is 3 to the power of 4. At this point, the bases are equal. So with this, we can equate the powers. So x minus 2 is equal to 4. Transfer 2 to the other side, so x is equal to 6. And we can always counter check this one. So if x is 6, so 6 minus 2, that would become 4, in which 3 to the power of 4 is 81. Another example. 2 to the power of 3x is equal to 1 over 8. At this point, the base is 2. So with this, 1 over 8 is the same as 8 to the power of negative 1. So rewrite 8 to the base of 2. So that would become 2 to the power of 3 to the power of negative 1. So simplifying this is 2 to the power of 3x. And 3 times negative 1, it's negative 3. So at this point, the bases are equal. So we can equate the powers, which is 3x is equal to negative 3. So simplifying, divide the entire equation by 3. So x is negative 1. Okay, another. 9 to the power of 2x minus 1 is equal to 27 to the power of x plus 2. Now at this point, you have here 9 and 27. So 27 and 9, we can rewrite these numbers to the base of 3. So with this, we can have 9 as 3 squared and 27 as 3 to the power of 3. So simplifying this, so 2 times 2x minus 1 is 4x minus 2. Then distribute 3 here, so that would become 3x plus 6. So at this point, the bases are equal, so we can equate the exponents. So 4x minus 2 is 3x plus 6. So combining like terms, so simplifying, x is equal to 8. So take note, this is equal powers. Another. Simplify without zero and negative exponents. So given this, number 1, we can apply power rule in which we can distribute the exponents to the terms inside. So with this, negative 2 times negative 8, that's positive 16, and negative 2 times negative 11, that's positive 22. Another example. 2 to the power of 0, x negative 3 to the power of 4 multiplied by x to the power of 12. So the same thing, we can apply power rule. So 2 to the power of 0 is 1. So with this, negative 3 times 4, so that would be x to the negative 12. So multiplying this, the same base, copy the base, and add the exponents. Negative 12 plus 12 is 0. Take note, any number raised to 0 is always 1. Another. 2a to the power of 2 divided by 2a to the negative 2. So with this, let's simplify the numerator. So that would be 4a squared divided by 2a to the negative 2. With this, 4 divided by 2, that's 2. And divide of the same base. So 2 minus negative 2 is positive 4. Another. Quantity x negative 5, y to the power of 4, z to the negative 3 to the power of negative 2. So still, this is power rule. So simplifying this, negative 2 times negative 5 is 10. Negative 2 times 4, that's negative 8. Negative 2 by negative 3, it's positive 6. So take note at this point, the exponent here is still negative 8. So you have to make it positive by bringing it down. So therefore, the final answer is x10 z6 over y to the power of 8. Another. Okay, 3, negative 2, x negative 3, y 4, divided by 6, negative 2, x negative 2, and y negative 2. So to do this, we can bring negative exponents up or down. So let's simplify. So since all of this denominator, the exponents is negative, so bring it up. So that would become 6 squared, x squared, then as is y4 and y to the power of 2. So since this 2 here, it's negative, so bring it down. So this would become 3 squared and x cubed. So with this, let's simplify. 6 squared, it's 36. X squared over x cubed, that's x negative 1. And 4 plus 2, you'll get 6. And 3 squared, you'll get 9. So with this, we can still simplify. The exponent here is still negative, so bring it down. So 36 by 4, so that by 9 is 4y6 over x. Another. Quantity x negative 2, y negative 3 over 2 to the power of 0, z negative 1, quantity negative 2. So with this, we can apply power rule. Distribute these exponents to the terms inside. So with this, negative 2 by negative 2, that's 4. Negative 2 by negative 3, that's 6. So 0 by negative 2, it's still 0. And negative 1 by negative 2, it's positive 2. So take note, 2 to the power of 0 is 1. So final answer is x4, y6 over z squared. One last. X to the power of negative 2 minus y negative 2 over x negative 2, y negative 2. So take note, all of the exponents here are negative. So bring down and bring up. So reversing this, we will have the equation x squared y squared over x squared minus y squared. So at this point, let's simplify further. We can have it this way. So x squared y squared over x squared and x squared y squared over y squared. So at this point, we can cancel x squared and x squared. So that would be y squared. We can cancel this. So what's left is this one. So final answer is y squared minus x squared. Okay, let's have this. John is asked to file a brick. Every layer will be doubled from the top such that the top or first layer has 1 brick. The second layer below has 2 bricks. The third layer below has 4 bricks, and so on. How many bricks are there on the 5th layer? So we can have it in tabular form. So take note, in the first layer, there will be 1 brick. In the second layer, there will be 2 bricks because it will be doubled. In the third layer, there will be 4 bricks. So it's doubled. In the fourth, double it. So you'll get 8. Double it further, we'll get 16. Or sketching it, we will have it this way. So from the top, it's 1. Double 2. You double, it's 4. 4 times 2 will get 8. At 8 times 2 equals 16. So with this, there are 16 bricks on the 5th layer. Okay, so let's have this one, rational exponents. So take note, an exponential form, 3 to the power of 2 is equivalent to 9. In rational form, reversing this, we will have 9 to the power of 1/2 is equal to 3. So how come it's like this? So take note, 9 to the power of 1/2. Take note, the exponent here is 2. So we have to rewrite 9 here to the base of 2 so that we can cancel. So with that, 9 can be written as 3 squared to the power of 1/2. Take note, 3 squared, it's still 9. So at this point, we can cancel 2 and we can cancel 2. So therefore, it is 3. So take note, exponential form, and this is the rational form. So again, in general, x to the power of n raised to the power of 1 over n is simply x because you can cancel n and n, just like what we did with 3/2 here. Now we cancel 2 and 2. Okay, now rules in rational exponents. So for negative exponents, so if the exponent is negative, so the same thing, bring it down or bring it up. Another product rule. So if you're going to multiply of the same base, so the same thing, you add the exponents, but this time it is fraction or rational. So just like this, so 1/4 plus 2/3. So simplifying, this would be 11 over 12. Another power rule. So if you have an exponential term raised to another rational exponent, so simply multiply the rational exponents. So 1/5 times 3/4 is 3 over 20. Another, it's power product. So this one, with the rational exponents, you can distribute it with the rational exponents inside. So 1/5 times 3/4 is 3 over 20. And 2/3 times 3/4, it's 6 over 12. Or you can simplify 6 over 12 by 1 over 2. Okay, then we have quotient rule. So the same thing, copy the base and subtract the rational exponent. So at this point, copy x, 1/2 minus 1/4. So that would become x to the power of 1/4. Okay. Then for power of quotient, so the same thing, distribute the rational exponents to the terms inside the parentheses. So let's have an example. Simplify the following. 81 to the power of 1/2. So the clue here is the denominator here is 2. So we have to rewrite 81 to the base to an exponent of 2. So that would become 9 to the power of 2, which is still 81 to the power of 1/2. So you might say, can I use 3 to the power of 4? It's still okay, but it would be good if whatever is the denominator of the rational exponent will be the equivalent exponent of the base. So at this point, we can cancel 2 and 2, so therefore it is 9. Another example. Negative 64 to the power of 1/3. So the clue here is the denominator is 3. So write negative 64 in which the exponent is 3. So with that, we can have negative 4 to the power of 3. Then still to the power of 1/3. So you cancel 3, so final answer is negative 4. Another. This time, 64 to the power of 2/3. Take note, the denominator here is 3. So rewrite 64 in which the exponent is 3. So with that, so still 4 to the power of 3 to the power of 2/3. So at this point, we can cancel 3 and 3. So that would be 4 squared or 16. Another. 8 to the negative 2 over 3. So take note, the denominator here is 3. Rewrite 8 to the exponent of 3. So with that, 2 to the power of 3 is 8. Then still to the power of negative 2 over 3. You cancel 3 and 3. So you'll have 2 to the power of negative 2, or that would be 1 over 4. Okay, this one. 25 over 64 to the power of negative 3 over 2. So take note, the denominator here is 2. So rewrite 25 over 64 such that the exponent will be 2. So with this, we can have 5 over 8 squared. Take note, 5 squared, that's still 25. And 8 squared, it's still 64. Then to the power of negative 3 over 2. So take note at this point, we can cancel 2 and 2. So that would become 5 over 8 to the power of negative 3, in which the exponent here is negative, so we will simply reverse the base. So that would become 8 over 5, then make the exponent positive. Take note, 8 cubed is 512, and 5 cubed is 125. That's how are you going to do it. Okay, let's have this one. 25 to the power of 3/2 minus 16 to the power of 5 over 4. So take note, rewrite 25 such that the exponent will be 2, and rewrite 16 such that the exponent will be 4. So with this, we will have 5 squared to the power of 3/2 minus 16 can be written as 2 to the power of 4 to the power of 5 over 4. With this, we can cancel 2 and 2. We can cancel 4 and 4. So 5 cubed minus 2 to the power of 5. So that would be 93. Another. 12 over 4 to the power of 3 over 2. So again, we write 4 such that the exponent will be 2. So in which it is 2 to the power of 2. So you cancel 2 and 2. So this would become 12 over 2 cubed, or 12 over 8, or simply 3 over 2. Another. 64x cubed over 27a to the negative 3 to the power of negative 2 over 3. So with this one, a negative 3, we can bring it up to make it positive. So that would become 64a cubed x cubed over 27 to the power of negative 2 over 3. It's just the same. So at this point, the denominator here is 3. So we have to rewrite 64 and 27 such that its exponent will be 3. So with this, 64 will become 4 cubed and 27 will become 3 cubed. So at this point, we can cancel the exponents, which is 3. So what's left is 4ax over 3. And at this point, it's negative 2. So take note, the exponent here is negative. So we simply reverse the base. So it will become 3 over 4ax and make the exponent positive. So simplifying this, so 3 squared, that would be 9. And 4 squared is 16. Then a squared, x squared. So this will be the simplified term of this one. Okay, another. Let's have this sample situational problem. Calorie is the approximate amount of energy needed to raise the temperature of 1 milliliter of water by 1 degree Celsius. It is important for the maintenance of body energy. A rough estimate of calories needed by an animal each day is calculated using the formula C is equal to 72 m to the power of 3 over 4, where m is the animal's mass in kilograms. Calculate the amount of calories needed by a 16 kilogram dog. So let's have this. So take note, C is equal to 72 m to the power of 3 over 4. So take note, the mass here is 16. So substitute 16 here. So we need to rewrite 16 such that the exponent will be 4. So that would become 2 to the power of 4. So with this, we can cancel 4 and 4. So that would become 72 times 2 to the power of 3, which is 8. So simplifying further, so the answer would be 576. So therefore, a 16 kilogram dog needs 576 calories daily. Okay, next. So again, wrapping up, the exponent says how many times to use the number in a multiplication. A negative exponent means divide because the opposite of multiplying is dividing, and a rational exponent like 1 over n means to take the nth root. Okay, so that would be all about rational exponents.